And welcome everyone. So today's workshop, the Lunch and Learn, is on Python. So welcome everyone. You all have a lot of different backgrounds. It's actually quite a range of technical background and the point at your careers that you're at. So this is a really awesome group. And I think it's really cool that we all get to come together, have some lunch, and talk about Python. From what I heard from everyone, I think you're each going to take something different. And that's it. And you can go home and tinker in your own way. So this will be a blend of conversations and tutorials and lecture and lunch. So keep eating, as we go. There'll be lots of opportunities to be eating, and also be open to talk. So before we get started, I wanted to introduce the Plot-A-Thon and where Python fits in. So one of the important things to understand about Plot-A-Thon is it's not about learning how to use technical tools, although that is a component of it. It's about learning how to distill stories from data and communicate those stories. So the tools that you use to find your data, analyze your data, and plot your data are not the same as the story that you tell. So there are multiple areas of development that you'll need to go through in order to tell a compelling story from data. And today we're going to focus on one element of that, which is learning one of the tools that you can use for a lot of those steps on the technical side. So I wanted to introduce then the general picture of telling a compelling story with data. And I'm going to do this on the whiteboard. If I can get my notes to show up. So I have learned how to do this. Okay. All right. Okay, so here's the process of data science. So I'm just going to write this out. Right. Yeah. Okay.
Also, you might want to cover one.
Okay. Got it. Legible?
Oh, yeah.
So I heard several people say that they were here to learn more about data science. So in the general process of data science, we start by thinking of a good question that we want to understand the answers to. So if we're doing data science for business or for analytics at a university, those questions might have to do with the business or the university. If you're doing data science for a research experiment, like physics, those questions may have to do with the nature of materials or stuff, or the nature of the universe. But the questions that you ask are ultimately the driver of the value of data science. So before you bother working with tools, you need to think about what kind of questions are you hoping to answer with those tools. So I'll put that as the first step here. So thinking of questions. That apply to your business or your university or your experiment, etc. The next step of data science, as I see it, is to gather a data set of relevance to this question. If you're a scientist, you may gather a data set that is a large collection of hadrons colliding. If you are working at the university, you may gather a data set of student enrollment numbers. Gathering the data set can be a long process. Or it could be a short process, and it depends on whether or not you already have the structure in place to gather a data set of relevance at your institution. So if you're a scientist and you want to understand hadrons or whatever, you might have to build an entire facility to gather the data set. However, when it comes to data science, you can't create narratives that answer questions without a data set of relevance. There's also a step here called gather, in which there may be potentially information that is available to you if you know the right people to ask and the right ways to ask them. And sometimes you may need to consolidate together data from a variety of different sources. So there's a lot hiding behind this step. After you have a data set of relevance, it's time to explore and clean up your data set. This is one of the first steps where you might actually use Python. Exploring the data set may involve making a variety of plots to better understand what data is in your data set. It may involve running statistics on your data, or it may just involve manual inspection of various elements in your data. It may involve asking new questions that you didn't think about and starting over in the process and gathering a new data set. It can also involve asking clarifying questions about your data set. For example, if you have a data set and you have some ambiguity of how it was collected, as you explore that data set by looking at graphs of it, by looking at manual inspection, you may need to go back to the people that collected the data and ask them about it to better understand what is actually happening in the data. By cleaning the data set, I mean looking at elements that maybe do not belong in the data, like maybe were mistakes, or removing sections or modifying sections that have inconsistencies that are due to the way the data was collected. Cleaning the data set can also involve simply refining it into a usable collection of data and reducing the number of elements. There's a lot here that are covered in different parts of Plot-A-Thon that you can explore. But you can use Python for this step as well. So we're going to talk about some tools for exploring and cleaning data sets. And then to get to the next part of data science for a problem, this is where you get into heavier analysis. I know we're getting kind of long going. Analyzing the data set involves doing more rigorous statistics, more rigorous computations than I would consider in the exploration step. You may dig deep into the question and try to understand not just what the answer to your original question was, but the why that answer is the way it is. And then finally, we distill that analysis, which is extremely complicated, and as deep as we have gone into the data, into a coherent story. And last but not least, we have to present or communicate that story. So this is how I see data science. And in a sense, we start at the human level. We go deeper and deeper into numerics, and we end at the human level. So getting between the big picture into the details and back to the big picture requires not just the tools, but the approach. The tools, however, are also necessary. And Python is one of the best tools that I can think of to exploring clean data sets, to analyze data sets, and to create the graphics and statistical tables and things like that that you will need as support when you tell your story. Okay, so now it's time for a conversation. So I gave a few examples of the kind of questions that you might ask if you were a scientist or at a university. So now I would like you to talk to the people at your table. And I'm sorry for the people online, I don't have a good way to do this. So maybe ask yourself. Talk about some questions that you might have about your area of interest. So for biotechnology, what kind of things are you thinking about? What kind of answers would you love to have that you feel are just out of reach, if only you could dig into the right data? So talk with the people nearby. You can spin around. And if you're online, you can talk with the team.
I mean, I've already had experience, so it's basically like plotting of certain things. For example, if you talk about heart rate and age versus heart rate, like what is the average of rate for 20 years and 30 years? It's like that. It's basically like
this percent.
Wait.
I was thinking about it.
Yeah, web applications. I don't think in web applications is obviously which basically I mean you don't get these thoughts.
Fingers crossed. Are you gonna have like things? Are you gonna like make a butt? Oh, you just like have like
Okay, 30 seconds, and I am going to be calling on Amber.
I feel like I almost say that I'm doing science. I wish it was that. That's something you can a lot of like the data, like the data. Based on people or registration, and the program that wants to do student or something like that. That's all like
Okay, so I could bring your attention back to the front. So now that you've shared some of the questions or explored some of the questions, I'd like to hear from just a few people. So I want to start with Amber, since she didn't get to talk with anyone because she's online and I couldn't figure out the breakout rooms. So Amber, what ideas or what kind of questions would you be interested in answering if only you could get kind of into the data?
So I would primarily want to look at things like what services students are using and how that affects their success outcomes. So things like retention, the rate at which they graduate. And that's kind of messy because students use a lot of services and they use a lot of them multiple times within a term. So that's one of the main things that I want to do.
Excellent. Thank you, Amber. Would there be any volunteer from this room? Ines?
Yeah, I have a question. Can you use it in clinical trials, for example, clinical research trials?
Yes, absolutely. Data science there's a lot of data science happening in bio, in medicine.
Yeah.
Yeah, and people are very much using data science tools to dig into large data sets about medical data. Yeah, and the kinds of questions that they might ask would be like, is there an effective correlation between this and this? Yeah. Maybe these two, maybe if you take this medicine, does it have an impact on X, Y, Z? I mean, there's a lot of different questions that they ask, but that's a very like low-hanging fruit level question that a lot of people want to answer about a lot of different combinations of drugs and effects. Yeah, thanks. Okay, one more volunteer, and then we'll move on to the tutorial. One more. Okay, thank you. And remind us of your name.
I'm Veronica.
Okay, Veronica.
So I'm interested to learn if whether in dyadic or one-on-one conversation, if humans are accurate or to what extent they're accurate in predicting the end turn of their speaking partners in the conversation.
Excellent. Excellent. Okay, so you have these questions. The next step would be to gather a data set of relevance. We're not going to do that in today's but you might imagine what kind of data set you might need to access. And for example, for a biomedical situation, you may need to do a trial, or you may find that someone has already done this trial and you can ask them for their data. Okay. All right, so now I'd like you to open up your computer. I'm going to sit down at mine. I'm going to share my screen, and we're going to talk about Python. Yes.
So you mentioned that we could ask for the data if data was already gathered. Is it possible to still use that data to sort even though the person who used the data before or the group used it before, say their own conclusions, just wants to kind of like shut the doors on it, or like is willing to give you the information but already had their bias on it?
Well, this is where it comes into the human factor, which is, are people willing to share the data sets that they have already created? And there's no technical answer to this. This is a question of politics and asking the right way and being the right person at the right time, talking to the right person at the right time. And none of this can be taught by learning Python. Yes. But it is so important to data science. Yes. But yes, you would have to take a human approach to that problem. Okay, yeah. Okay, so I'm trying to share the whole screen, but I'm not seeing an option. So I'll start by sharing this. So what I'd like you to do is open up the Anaconda Navigator. The way I did that on this computer is from the Start menu. So hopefully you can also get that open. Once you have it open, you'll see that there's a variety of different things associated with this software. The one that we're going to use today is called Jupyter Notebook. Quick launch. While that's launching, let me tell you a bit about the tools. Green is the good one. Okay. Maybe black. Need right picture. I have some marker stuff. Do the big. Okay. I need heavy duty. This is heavy duty. Is this like permanent? There we go. Feels like very nice. Okay. Oh, this is so. Once again. Thank you. Okay, so let's talk about this. So I have you download something called Anaconda. As you all know, an anaconda is like a species of snake. So it's a play on words here that there's Python is the like core software or core programming language. And Anaconda is this package which contains Python and a variety of tools to use Python. Yeah. You can download this. Yeah. Yeah. You might be able to get someone to help you right now if they're feeling hurt or anything. They can help you get it. So under the umbrella of Anaconda, you've downloaded a variety of different items through that one download. First, you downloaded the Python programming language. Second, you've downloaded a variety of tools for using the Python programming language for writing Python programs. And one of those tools is called Jupyter. So a Jupyter Notebook lets you write Python programs in a way that is conducive to data science applications. And one of the reasons that Jupyter Notebooks are so nice is because rather than just writing computer code, you also write human readable comments. So another way to think of it is you could write a whole paper in Jupyter Notebook that had no computer code whatsoever, and it would look beautiful. Whereas if you wrote a Python program without something like Jupyter Notebook, it would look like computer code. So this is a really nice tool because it lets you blend regions of a document that look like an English essay with headers and subheaders and links and things like that, with little blocks of computer code that can actually run. So we'll come back to this diagram here after we get into this one. So back to the screen. You should now have something open like this. Have that. And what's really cool is Jupyter Notebook runs in your web browser, so you can use like Google Chrome or Firefox. Even though it looks like this is on the internet, this is not on the internet. What it's doing is it's using your computer web browser software to run a program on your computer. So next, I want to show you a bit about how to make a new Jupyter Notebook, which is the main thing we're going to be talking about using today and writing programs. So I'm going to just go into my documents, and I'm just going to make it here because I don't have a strong preference of where I make my files on this computer, since this isn't even my computer. So what I'm going to do then is I'm going to say new Python 3, and you see here it says notebook. So that will launch me into this new editing interface for a Jupyter Notebook. I want you to take a minute and call it something informative. So in this case, I'm going to call this hello world. Because that's what we're going to do in this notebook. So this is my hello world notebook. In my documents, you can now look and see that there's a file called hello.world.ipynd. This stands for Python notebook. And the file itself is open in this other tab. I'd encourage you now to take the user interface course. You go to help, user interface course. This only takes a minute, but it's going to save you a lot of time. Yes, let me just help you set up. So, okay, thanks. I'm going to watch for people to be done, and we'll resume.
So do all of this. Yeah, I'm gonna shoot.
Okay.
Yeah. And I'm going back.
Good. That's perfect. That's exactly where all are welcome at all levels. Okay, so hopefully you finished the interface core. There's a lot you can learn about Jupyter Notebooks, and you can become really fast at writing them and stuff. But I'm not going to have time to go through like every part of the interface, so you'll have to come back and explore that later. But what I want to show you is that at any given moment, your cursor can be green or blue. If it's green, you're actually editing what's inside of this little block, and if it's blue, you're kind of like in what they call like command interface, where you're at a higher level and you're able to make new cells and things like that. So if I want to make a title, I'm going to change this to Markdown. Markdown is the same language that you use if you're like editing a wiki article on like Wikipedia. And you don't have to know all the details to basically do stuff in it. One of the most important things to know is that hash marks mean headers. So the more hash marks, the lower the header level. So if I want to make a title, I'll just make one hash mark and press space. And then I'll say, my hello world. Now, to run this cell, which in this case is a markdown cell, I do shift. At the same time, I then press enter. And now I have this title that says, oh, my hello world. My next line is once again in code format. But since I'd like to write more in this document that's not code, I'm going to switch it back to Markdown. And then I'm going to describe my code.
So,
okay, so write whatever you'd like. When you're done writing, since I have no hashtags in front, in Markdown that means just regular text, not a header. When I hit Shift Enter, it just turns it into regular looking text. So as you can see, if you wanted to write an essay, this would be all you need to know. You don't need to know any Python to write a beautiful document in Jupyter Notebook. But the point of something like Jupyter Notebook is indeed to write some computer code. So let's write a little computer code. In Python, to say hello world, you use something called print. Print means like print it out on the screen. And then you do brackets. And whatever you put inside in quotes will print out. So if I want to print out hello world, that's how I would type that out. Something to notice here is the name of this function is called print. It's part of Python's basic functions library. Like that means that you can always use it. Whatever you want to print out needs to go in parentheses and in quotes. When you're done with that, just like you did for the text sections, you shift enter. And that's the end of this particular notebook. So let me just walk around and see if people got this. You did it. Good job. Very nice with the different levels of color. That looks like a lot more than the world. So you're good. This is open to all.
I just.
Okay. All right. Very good. Love it. Okay. So we're done with the hello world script. Okay. So what we can do now is we can save it. It looks like it auto-saved, which is nice. You can also save it deliberately. This. And then go back to my documents. And it's time to make a new notebook. So what I did here is I went back to my documents tab. I'm going to make a new notebook. This one I'm going to call I'm going to call this one Basics of Python because I'm going to talk to you about some basics of Python. So this is the name of the file. So if I go back to documents here, you see you made a new file called Basics of Python .ipython notebook. Okay, documenting your work in Jupyter Notebook is so nice. So you get really fast at it. So right now, see how it's green? If you press escape, it'll turn blue. And then you can just press M, and it turns into a markdown cell. So you kind of get, basically what I'm saying is, you kind of start to like the shortcuts, if you're like me. But you can also use the way where you do the drop-down menu. Since you're blue, you can't really type yet, so you need to hit enter again to get back into the cell. Okay, now I'm going to title it. So, okay, so that's once again a markdown cell. I'm going to hit escape. I'm going to press M. I'm going to hit enter, and now I'm going to edit my text. Okay, so as I was doing this, after I was done typing, shift enter. What if I realized I had a typo here? I can just double click it again and change it. Okay, so what I'd like you to do now is make a new section. This is a check your understanding moment. I want this to be at subheader level 2. So that means 2 half marks. You'll need to switch this to a markdown cell. And I want you to call this types. That's what the section will be called, types. We're going to learn about different types of data in Python. what I'd like, the hope that you just did, you put mark down, you did 2 half marks, and you did heights, distance.
Yeah. Yeah. Yeah, well, this is part.
Okay, once you have this section, I'm going to show you how you can set a variable to a value in Python. So let's say A is 5. B is hello. C is 1, 2, 3. D is no, I won't do that. There's one more. Oh yeah. B is false. You see D, E is done. Then do F. Oh, I didn't mean to do that. Okay. After you've got those all set, hit enter. What you've just done here is you have defined 6 different variables, each of a different type. When we talk about types of data in Python, we need something very specific because these different bits of data all have different values, but also a range of possible values associated with them. And they also have methods that you can use because of their data type. So for example, the data type of A is an integer. Yeah. Is this too small? Should I make it bigger?
Yeah. After F equals, is it 5 comma or 5 point?
Okay.
Ah.
Okay. Yeah, sorry about that. So what we have here is A is an integer. An integer is like a whole number, but also negative whole numbers. If you think back math, what an integer is like. -1 is an integer, plus 25 is an integer, 5 is an integer. B, this is a word, right? Like in common language. But in computer terms and in Python terms, this is called a string of letters. So it's like a bunch of letters strung together. It's a really weird way to think about words, but any text-based data is called a string, typically in Python. This is a list of numbers. This is true or false, which in computer terms and in Python is known as a Boolean data type. This is a special type that's called none type, which represents none. And this, since it's a fractional number and it's not an integer, is known as a floating point number. Don't worry about the jargon there, but that's just what they call it. In Python, you can check what kind of types you've got by the command type, function type, and then you just put the thing you want to check. So type A is int. Type B is string of letters. Type C is a list. Type E is Boolean. Type E is none type. Super special type. There's only one thing in none type, and that is none. It's got no type. Yes.
Would that be considered the equivalent of null or like
Yeah.
0?
Yeah, well, not 0,
Oh,
because 0 is an integer.
Oh,
And not true or false, because those are booleans. Just like, I don't know, It's kind of like the Game of Thrones. Not a person or whatever that person says. He is not a type. Okay. So that was a quick introduction to types. I said that types have both data and methods. Let me give you an example. So the kinds of things that you can do with a number is you can add them together. And so A actually has methods related to adding. That means that you can look at A and do things like addition. But a string might have methods such as concatenate, because you can concatenate together strings of letters. A list might have methods such as append, because you can add elements to the list. Or iterate, because you can work your way through the elements of a list. True and false, I don't know what kind of methods they have, to be honest. None, I can't imagine having many methods. And then floating point would also have numeric methods like addition, subtraction. So this is kind of weird, but if you go look up like the string type on the official Python documentation, you can learn. So you just look up a Python string, ignore these are like too crazy. But instead go to the official docs. These are all the data and methods that you can use with a string. So for example, anything that you would read on this page, you can use with B, because it's typed as strings. In addition to these basic data types, there are more advanced types. And this idea of giving everything, like every variable, both data and methods associated with that data, is called object-oriented. And so we would say that D is an object of type Boolean with data of false and methods of whatever methods it is. We would say F is an object of type floating point with data of 5.1 through 23 and methods such as add, subtract, divide, multiply. So you may have heard the term object-oriented programming and not known exactly what it was. It relates to this idea that everything in your computer program is considered as something with both data and methods. And you can either access the data or you can access the methods of that object. If you want to get really crazy, you can see what kind of data and methods it has. Oh, that is not at all what I meant to do. If you do a dot, for example, these are all methods in data of an integer. I can convert it to bytes. I can find the conjugate, things like that. If I do v dot, I'm going to get all sorts of different methods. Like, do I want to capitalize my string of letters? There's a method for that in the string type. That didn't do what I thought it would. Oh, it probably just capitalizes the first letter. Let's find a different method that makes more sense. So there's a method. These are all in the official documentation but let's say the method upper. This method changes my string of letters to all uppercase. So the data in B was hello. One of the methods was upper. When I call that method, I made all my data uppercase. The reason I'm like talking a lot about this particular thing, even though we have limited time, is that understanding that everything in Python has, every object that you write in Python has both data and methods will go a long way towards understanding a lot of the stuff that you're going to do with data science with. So now let's take a hyper jump and talk not about the basics of Python in particular, but let's jump all the way over to some of the extensions or packages that you can bring to Python to give it all sorts of different capabilities that do not come with the Python programming language by default. So one of the things that makes Python very interesting and useful for data science is not just that it's a great programming language, but that there's a great ecosystem around it. And just like you might install your favorite plugins or your favorite software, you can install all sorts of extra third-party packages for Python to do all sorts of things. And you like really all sorts of things. Like there's an astounding number of packages developed for Python. And in the Python ecosystem, it's easy to install new things and take them away. And the whole thing is built around this idea of modularity. Anaconda came with a lot of packages already ready for you to use. And that's why I had you, instead of just go and download Python, I had you download Anaconda. One of the packages that it came with was actually Jupyter Notebooks. Another one is called NumPy or numeric Python. Oh. Numeric Python is the foundation of almost every other package in data science because it provides all sorts of extensions for Python that let you do high performance computation with numbers. So regular old Python can do math, but numeric Python can do it really efficiently and like really hard math. Is basically one way to yeah. So lots of data science packages actually use numeric Python as the basis. One of those packages that uses numeric Python as the basis is called pandas. Put a little arrow there to indicate that there's no pandas without numeric Python. So the people that built pandas use numeric NumPy throughout. So sometimes even if you don't mean to use NumPy, if you use pandas, you'll find things about NumPy in it. Another package that uses that data science is very much facilitated by and that also uses NumPy is called Matplotlib. This is a weird name, right? Matplotlib. But it's a plotting library. This is great for making plots. But it's not always super easy to use. So just like someone came along and built something on top of numeric Python that's even easier to use than just NumPy by itself, someone came along and built something on top of Matplotlib and pandas that brings them together and makes plots really easy to make. And it's called Seaborn. So Seaborn uses Matplotlib and pandas in it. So the reason that I'm giving you this kind of like flow chart here is because if you follow some online tutorials on data science, you might start with Seaborn, but then you might run into parts where they start doing things with Matplotlib or Pandas or NumPy. And you might get really confused. But now you won't, because you realize that Seaborn is just one more layer above these other things. Pandas is one layer above this. And then Matplotlib also, I didn't want to draw an arrow crossing them. You realize I'm not typing. These are some of the best libraries for getting started with data science in Python. And they've all been downloaded as part of that. I hear that's a conversation. Are there some questions based on what I was just talking about? Okay, so in this lunch and learn, I don't have time to go into all of these great packages, but what I do have time to is to teach you how to learn effectively about these packages. So there's ways to learn where things are really confusing and ways to learn where you actually get to know what you're doing. And so let me talk about a couple of those ways. One way you can go about learning to use something like Pandas or Python is to just search like Pandas and just like kind of, well, first of all, that you're going to find a lot about Pandas, but and click on the first link. So yeah, there's nothing wrong with this. Like this is a good starting point, but you need to learn about the official resources. You are students and you're here not to find just like what was already online from me, but to hear like what a professional perspective is. So these are great tutorials, sure, and you can follow them, but there are definitive references for each of these. And by definitive, I mean they have every possible bit of documentation that you could ever have. If it's not in it, then it's not in Pandas. Or if it's not in it, it's not in NumPy. Or if it's not in it, it's not in Seaborn. And the key term here is called API. API is the official definitive reference for a package in Python. So the way I would recommend then finding your definitive reference for each of these, for example, is to search NumPy API. This, okay, that's not it. That's because we're using things. This is what usually comes up. This is the official API reference for NumPy. And so if I want to know what kind of data and methods are in a data type that I use called NDArray, then I can follow this through, and this will have every single possible data and method listed out. These are a bunch of data, these are some methods. And so a lot of tutorials have you use data and methods from various types, and it's hard to know then how to get creative with it because you kind of only know exactly what they said in the tutorial. The API is the definitive reference where you can learn everything about that. Similarly, you can find the same thing for Pandas. Like, let's say I want to know all the different methods of the data type called data frame. This is literally every single attribute, which is the data, and method, which is the function that you can use with the data frame. Same for Seaborn, same for Matplotlib. So in summary, when you're looking for the definitive reference for any of these tools, it's called the API, not Geeks for Geeks or W3 Schools. And once again, if it's not in here, it's not part of it. So it's really a nice relief because it's like the definitive documentation. That's not always the gentlest starting point, but it's great to have on hand when you're working with it. So let's make one more notebook. This is going to be a crash course into the data science, and I'm going to show you how you can use the API documentation as you work through this. So in this little session, we're going to look at some data for the Titanic and make a plot. So practice making a title. What is that? Okay, so I use this data set because it's actually available without actually even downloading anything, which is kind of nice. So the first step you'd want to do is import some modules. So this is the part where you say, in addition to regular Python programming language, I want to bring in these third-party extensions like NumPy and Pandas and Matplotlib and Seaborn. So you'll commonly see that you'll give shorthand names for these modules. So NumPy becomes NP. Pandas can become PD. You'll see people say, I actually just want one part of Matplotlib, the PyPlat part, or Python parting plot, and I want to call it PLT. And then you'll also see people say, I want Seaborn, but I want to call it SNS. That's what this syntax is referring to. So the next step is to load in the data and examine it. You could use pandas functions like read CSV. And if you wanted a definitive reference on that function, you could go look it up where. Yeah. So let's look at pandas. And let's look at the pandas read CSV function. We're not going to use it. Oh, it's because it's covered. Here's the search bar. All right, so there's a function called read CSV. Did you ever want to know all the options? It's in the API. So this describes every single possible way you can use the read CSV function. But I'm not going to use the read CSV function today. I'm going to use the Seaborn function called load load dataset, which here you see what it will do is load an example dataset from the online repository. It's going to download it for us, and you can pick any dataset from here. But there's a lot. I'm going to download the Titanic. Yeah, the API. So you've probably seen in tutorials people say like seaborn.load dataset to get something, but the API says all the possible things you can get. So here I read the documentation for load dataset, and I saw that you can actually specify any dataset in the format of name.csv that's on this link. And there's lots of datasets here. We're just going to do Titanic especially because we're short on time. So I'm just going to kind of plow through the rest of this.
one question. Is it only from GitHub or are we gonna be given data set during Plot-A-Thon through a different website?
Yeah, so you can get data sets anywhere, and you would then use functions like read CSV to load them in. In this case, I'm using a function called load dataset to load in something that already is available to everyone that uses Seaborn. So there's this method. If you look at the API, it's called seaborn.loadDataset, and this method loads in a dataset, and it outputs a pandas data frame, which now you know is because of this little hierarchy where things are built on one another. So you can specify some optional arguments, such as any argument that starts with something equals is optional, and you have some required arguments which don't have that same syntax, they just say name. So this is the only required argument for this method of Seaborn. The name needs to be type string, and it needs to be something of the form name.csv where it matches something on this website. I picked Titanic.csv. I will put my request in the format of Titanic, and it will return a pandas data frame. And so rather than kind of just like not knowing what I'm doing, I know exactly what I'm doing because I'm looking along with the API before I call my functions. Okay, so this just loaded it in. If we want to look at a data set, we now know what we need to do. We need to know what kind of type it is. This is a data frame type from pandas. Where do you think I can go to find out the kind of methods that I can use on a pandas data frame?
Pandas API.
Yes, the pandas API. So, like I said, I'm really teaching you how to teach yourself here. So we go to pandas API, search for data frame. There it is. Look at all, so this is all how you make a data frame, but look at all these different, you scroll down, attributes and methods. One of the methods that I like to use, and you wouldn't like necessarily find a method here unless you're like really digging deep, but you'd be able to go find out exactly all about it here after you kind of follow the tutorial online. So one that I like is called info. This prints a nice summary of the data frame. So let's give it a try over here. So this is what's in the data frame. We have several rows of data. We have several columns of data. One is called survive. One is called fair. One is called class. The data types are different for these different columns. For example, the fair is a floating point number, which means it can be fractions of a whole number. Whereas whether this person is an adult male is a Boolean, true or false. And the dec is a categorical variable with multiple possible values, like dec A, dec B, dec C. Whereas the whether the, I don't know, I actually forget what these are, but these are integers. I guess like passenger class is the better example, is an integer, because you can be class like 1, 2, 3, or 4. Okay, in Jupyter Notebook, you can also just type the data frame and it will give you a nice, pretty formatted stuff. How do you think I could learn about the data and methods of the N64 data type? Yeah, that's right. And weirdly, this would probably be in the NumPy API. That's funny. Okay, so moving my way through here. let's get to some exploratory plots. So we're going to use some seaborne plotting functions to just jump immediately to some really cool plots. So one kind of category plot that you can do, one kind of plot you can do is a category plot. And you can explore other kinds of plots on the Seaborn webpage. But if you do a category plot, that will break your data up into some categories. So let's look at some categories of survival. So our x-axis will be the survival, our y-axis will be the sex, and let's see what that generates. So it's giving us an error here because I typed it. Did I type it wrong? Oh. I forgot to put in the data. Okay, so here we have x value, we have y value, and we have the data. How do you think I knew that was the syntax? I followed the Seaborn tutorials, but if I wanted to know every possible input that I could do, I would go to the Seaborn API for category plot, and you would be able to find all the details there. All right, then I want to wrap it up with one more plot here that is more meaningful. So let's look at a histogram plot of survival by sex. So what we have here is we've used Seaborn's plotting function called histogram plot. And we're looking at, on the x-axis, male or female. And then on the y-axis, we're doing a histogram of the number of entries that survival is marked to true versus false, or actually marked as 0 or 1. And so the hue then is choosing between whether this is survived or not. So if you look at this whole chart, it's a histogram of the breakdown of the members of the Titanic by sex. But then within that plot, we looked at the survival rates of that particular category. And so with very few steps, we've made kind of an interesting analysis or an interesting plot here describing the idea that there were a lot more male than women passengers on the Titanic. And of those passengers, a lot of men fell in that 0 category of survival, as well as a lot of women fall in that 0 category. So getting much deeper into this requires a lot more training. So let me just leave you with some key takeaways. We would not be done at the point where we make a plot. We would now need to explore what the meaning of the data that we just plotted is, understanding how the data was collected, and then we would need to decide whether this story was compelling in respect to some of our original questions. Finally, we have to think about how to communicate this, and we probably make 20 plots and take maybe the best to communicate our story. As you work through Python tutorials, remember where the definitive references are. They're called the API. And whenever you're using a method, you'll want to go look it up in the API to really understand what it's doing. And then finally, Python is a wonderful ecosystem for data science with lots and lots of third-party packages. Take advantage of it, and you'll be able to have the tools which you need to tell compelling stories with your data, at which point you'll be ready then to learn how to use those tools to tell stories. All right, thank you.
There was in the online.
Oh, okay.
But I'm not sure.
Is.
I did not see that question, but feel free to ask again.
Sorry, I had a question.
Okay, what's up?
I'm not sure if I missed this, but are you only able to load in CSV files or are there other file types?
Oh, yeah, you can, Python, if the file type can exist, Python can load it. It's just a matter of which third-party package you need. Or for most file types, you can just use one of Panda's methods.
Okay, cool.
So like, CSVs are definitely one file type. Python is like a Swiss Army knife. You can do anything.
Got it. Got it. Thank you. And thank you especially for managing like this online component and the in-person stuff.